Right, thanks for coming everyone. When I set out to do a talk about messaging, I didn't set out to do a talk with every single buzzword that was going in the .NET space at the moment. It just kind of ended out that way. I found it quite a useful way of doing some of the demos. So hopefully you should see something that's of interest to you and some technology we might consider cutting edge, and learn something a bit about messaging and messaging systems along the way. So my name is John Staveley. I'm a contract .NET developer based in Leeds. This is the fifth time I've done this talk, various places across the country. I'm an organiser at LeedsSharp, so we have various speakers around the country come to there. And I've been using messaging systems quite a lot in the last few years. Microsoft Message Queue, RabbitMQ and Azure Service Bus. So what am I going to talk about tonight? So first off, why use messaging systems? What kind of problems does it solve? What new capabilities does it give you? What are they and the benefits? Then I'm going to do three quite large demos. So the first is with Azure Storage Queues, then the second Azure Service Bus and RabbitMQ. So these type of messaging systems that are widely used out there in the wild. So I'll also be talking about something called Azure Functions. You may have heard of AWS Lambdas. They're the Azure version of Lambdas or functions as service and what they are. So I'm going to do a couple of instances of infrastructure as code. So this is automating the setup of the infrastructure that you use to run your code on. Because we're all tech hipsters, of course, I'm going to be using .NET Core and Docker just to illustrate some of the benefits of those approaches. And I'm going to talk briefly at the end about other messaging implementations and some of the different technical things you need to consider when you're implementing messaging. Usually people are sort of phasing out. I've been bombarding them with information for over an hour and a half by that point, so I kind of rattle through that section. So all of the code for this is on GitHub. I'll put the slides and a link to GitHub at the end, so you can have a look on if you have any questions. Slides and SlideShare. Okay, so why would you use messaging? Well, one of the main cases is distributed workload. So you might have spikes in activity where lots of activity comes in and then nothing. So you need lots of workers going against your workload and completing it as fast as possible rather than running on a single instance. So classic example is where you've got an HTTP endpoint that needs to do some work, but you don't know the load distribution of that. So if you get a sudden influx of work, then it could start overloading that API and dropping out. So that helps with increasing reliability. So again, with the case of an HTTP endpoint, that connections against that might drop, particularly if there's an amount of work being done at the back end and that takes some finite amount of time to be processed. Did it fail on the way there? Did it fail on the way back? If all you're doing is posting a message to a message queue and then that's getting processed by some other work stream, then it can act as a buffer in your system and increase the overall reliability. So if you're doing microservices, so you want to practice something called systemic loosely coupling of the systems. So a chief means of doing that is via messaging systems, principally pub/sub, where one system is letting know other systems that are interested in changes in data. So you typically do that by messaging systems. And the promise of fast reads and fast writes. So for instance, if I like Kevin on Facebook, then that like's registered, and then it's stuffed in a queue and processed, and then when Kevin goes on his feed, then the view of that data is pre-built with the number of people who liked it and all of the comments. So it's not happening synchronously. So I'm fast writing it to a queue and then reading it out, because that view that he takes of that data and all the other aggregations on that data is spat out waiting for him. So again, another application of messaging systems. So who's using messaging? LinkedIn, Compare the Market, Facebook, pretty much all the big players are. So I'm going to do a quick demo. So the first demo is going to use using the Azure portal. We're going to talk a bit about serverless or functions as a service, as I prefer to call it. We're going to be using Azure Storage Queues as the means of delivering the messaging. I'm going to demonstrate two messaging patterns. So the one-way pattern and competing consumers pattern. Right, so very briefly, what is Azure? Who knows what Azure is? Okay, some of you. So it's the second largest cloud provider in the world. Does infrastructure as a service, so that's Windows or Linux VMs to you, platform as a service or IaaS on demand, and functions as a service or serverless, so Azure Functions. You can do data storage, blob storage, SQL Azure, which is the SQL version on Azure, Cosmos DB, which used to be called Document DB, which is a document structured database, HD Insight, which is their version of Hadoop, and Azure Data Lakes, which is their extension on Hadoop. Notifications, web load balancing, Active Directory as a service, Application Insights, which is their logging as a service, Azure Machine Learning and Cognitive Services, so these are things like image recognition, text recognition, speech to text, intent, that kind of thing. And of course, message queues. So we're going to be looking at Azure Service Bus, but there's event grids and a number of other different types of messaging. Each have their own pluses and minuses. So their version of infrastructure as code, which is what the infrastructure I set up, if you've not heard the term before. So when you're doing an MVC application, you right-click deploy. What are you deploying on? Well, you've got IIS there, you've probably got SQL Server, a SQL Server database, you might have messaging queues. With infrastructure as a code and using their ARM templates, you can set all of that up and parameterize it for different environments like integration, regression, QA, UAT, and that lot. So all of that automated, all repeatable, lots of benefits. So Azure Functions. So serverless represents a paradigm shift. So if you're looking at processing distributed data, then Azure Functions is probably the one to look at over sort of like the actor model or microservices because of its auto-scaling properties. I prefer the term function as a service because obviously serverless, it does involve a server somewhere, you're just not managing it, and that's why it's called serverless. What is an Azure function? It's an event, so it's responding to something that's coming in, which could be a clock ticker, or it could be an HTTP endpoint, or a message on a queue, and some code. So how is it then processing that data? It can respond to a number of triggers, so as I say, schedule, which is a timer, HTTP, queues, or storage. And then it has a concept of bindings, so where does it put the data out that it's processing? You can program in JavaScript, C#, PHP, or PowerShell. All the options are there. And one of the key things about them is they're stateless. And this is important because if it wasn't stateless, then it wouldn't have the auto-scaling property. So what I mean by auto-scaling is that it responds to load. So for instance, if you've got a binding to a queue and it detects that that queue is backing up, it will then create another instance of itself. So you're then working, you've got two instances working, all of that data coming in. You can try it for free. You can try Azure Functions, I think is the website, and you get a monthly grant of 1 million executions and 400,000 gigabits per second. So you need to do quite a lot of processing before they start charging you any money for it. But it's well worth a look at and a play with. One key caveat to mention though is the execution time is limited to 5 minutes. So this is not for intensive numerical processing. This is some small bit of discrete bit of code that does some processing and then finishes. You kind of get some monitoring for free. I'll be doing a bit of that. It's not application insights or Stackify or anything, one of those, or even these guys. I can't remember the name. What's the name? Raygun. It's not Raygun. It's basic, but it's there. Yeah, you can try it online for free. It can be edited inside the Azure portal. I'll demo that in a second. And edited and deployed from Visual Studio, just as you would with an MVC project, right-click deploy. So, what are the different Azure queuing technologies? So none of these have been superseded, I have to say. They've all got different use cases and different problems they solve better than the others. So it's not like event hubs of superseded storage queues. There's still a use for them. So the storage queues support standard operations like get, put, and peek, and it can store over 80 gigabytes in the queue. So that's quite a lot of data. However, if ordering is important to you, it doesn't offer any kind of ordering guarantee. So it's not first in, first out. It's just, we're chucking this data in a bucket, and if you read from that, we'll give you some data. But we're not making any assurances about what order it's coming in. And it's cheap. That's not to say that Azure Service Bus is expensive. It's kind of like 0.00001 of a pence per message as opposed to 0.001 pence for Azure Service Bus. So if you're doing lots of data and you need it to be extremely cheap, then storage queues are a good option for that. So the second option is Azure Service Bus queues. So they brought this out. This is all in chronological order. Second off, now this can support message exchange patterns. I'll be talking about what the patterns are later and the kind of things that they offer you. So you can do something like publish, subscribe, and topics. More on that later. It doesn't require polling. So the thing with storage queues is you have to go, have you got a message, have you got a message, have you got a message, and you keep continuously polling the queue. Whereas Azure Service Bus queues, it just maintains a connection to the service bus, and if there's a new message on it, process it straight away. But there's an 80 gigabyte queue limit. So if that's important to you, then maybe Service Bus queues is not for you. It supports the Advanced Message Queue Protocol, which is a very standard interface for message queues. So that's sometimes important when you're writing APIs. And it can support at most once delivery. So some of the reliability characteristics I'll be talking about later. So it's also, it's a brokered implementation. So some people think that when it's a brokered implementation, it's a single point of failure because everything goes through the broker. However, their way of overcoming that single point of failure is by using partitions. Now the next one they brought on was event hubs. So this is when you've got fire hoses of data, really very large amounts of data. So if you've heard of Kafka, that's the big one in the market at the moment. LinkedIn use it. They process trillions of messages with it every day. So Event Hubs is kind of like the Azure version of that. And it can deal with huge scale or streaming. So you can do queries on the stream as it's passing by. It supports Advanced Message Queuing Protocol or REST. There's also a fourth one they've just brought out, and that's more for sort of IoT applications. So in terms of the patterns, the first pattern we're going to look at today is the one-way pattern. So you've got a source of data, which then talks to a message broker. The message broker says, well, I'm going to put it on this queue. I'm linked to this queue here. And then I've got a consumer here of that queue. So we're going to give it, on the Azure function, I'm going to give it a workload. I could have just done hello world or 1+1, but I thought, just make it a little bit more interesting and challenging. So we're going to calculate the factors. If you remember from GCSE maths, those are the factors. So it's the numbers that are divisible into this number. So given a number, these are the factors. So it takes some time to process, and that helps demonstrate some of the auto-scaling capabilities. So what we're going to build is we're going to build a source of data. So I'm going to use PowerShell in this example as a source of data. We're going to expose a REST API very easily using an Azure function. The Azure function then posts onto a queue. And then the queue is read by the factor calc, so that does the factoring. And then that then posts the result back to a queue, which is then read out by a consumer. Okay, so I've created an Azure function here. So I've just done create new resource and Azure function. So this function is called HTTP factor number. So in terms of its binding, the trigger is on an HTTP request and the output is again via HTTP. So if you have a look at the code here, it takes as a dependency its log and the HTTP request. So that takes the data in. This is a bit of boilerplate that just pulls the value out that I want, and this is what calculates the factor. So then it returns the factor, and then I reformat that, which is then put in a response back here. So if you have a look at manage, no, not manage. Okay, so the only thing I've changed here is the authorization level. So this is anonymous, so I haven't had to set up any kind of security, so I can now call the endpoint. Now, interestingly, if you have a look at what's going on behind the scenes here, with Kudo tools is actually set up a full version of IIS with web.config to surface this for you. So it's standard technology that it's deploying your function in a different way. So you can just copy and paste your code to this and you're up and running. So this is the endpoint here. Let's copy that to tool. And then I've got this test thing here. So for instance, I'm going to take this request body, it's a JSON thing, and post it to there. And hey presto, hello 999, you have 8 factors and the factors are blah, blah, blah. Now here you can see some of the logging appearing in the window below. And that also appears in the monitor tab here. Okay, there's some I did earlier. So this hasn't caught up yet, the one it will eventually. Now I've got this PowerShell script here. So there's my URL, and this just generates a random number and posts it at that API in exactly the same way as the other one did. So if I just fire that off. So this generates a random number, fires it off, and then outputs the result here. So they're all my factors. So again, this appears in here in the log. Right, great. Okay, so that's a basic HTTP endpoint with the result shown to posted back to via HTTP. So now I'm going to do the demo I was talking about here. So you can use the same PowerShell script to generate the data, calling against the REST API, dump the data to a queue, calculate the factor, dump it back to a queue, and then read it off using a consumer. So what do I have to do for that? So here's my function, receive number to be factored. And again, we've got the dependencies injected into the method. So here I've got the dependency of the out queue, which uses the iCollector interface. So bit of boilerplate, deals with bringing the JSON out, and then all I do is log it and output it to the queue. So if you look at the integrate tab here, we can see there's the output queue stored there, and the trigger is the HTTP. So further down the chain, you've got the calculator factors at, so that reads from a queue and then writes to a queue. So we're expecting 2 dependencies, and then yeah, so there the number to be factored is read off there, calculate the factors, and then the output's written to the queue. Okay. So final bit of that. So I'm just going to post a message to receive number to be factored. And we can have a look using the Azure Storage Explorer. Now there's nothing in the numbers to be factored queue as you'd expect, because the downstream queue has read that number out and processed it, so that's been taken off. But we should see one in factored numbers. So there you go. So there's my hello, blah, blah, you have 24 factors. Right, so this is my Azure Storage Queue factored numbers receiver, which is just a small console application. So it being Azure Storage Queues, you'd expect there be some polling, which there is. So we do through this do while loop, reading out the messages in the queue, and then you set the message to delete once it's been processed. and do some niceness around telling the user what you're doing and setting up the interface with the storage queue. Okay, so we should see one appear straight on here. That was the one that was sitting in our Azure Storage Queue. So that's now gone. And then let's post another one. Poll, poll, poll. Right, there's the result. Okay, so let's say we've got a spike in demand. So suddenly my world-beating factor calculation routine is really popular. And I need to process a lot of data. So with any luck, that should say 102. Still polling, still polling. Okay, it will come through eventually. Right, so source of data, REST API, writing to a queue, factoring, writing to a queue again, and then consuming the result. Okay, so we've been through that, but what I didn't tell you is that we're actually doing two patterns at the same time. So because we're using an Azure function, it has a rather smart property, which is auto scaling. So as soon as the messages start backing up here, this function goes, oh, hang on a sec, I've got too much work to do. I need to create another instance of myself, which it does using various heuristics, the amount of time that the messages have been left in that queue. So what we've been doing is looking at the second pattern I want to talk about today, which is competing consumers. So this is where you have a source of data routed to a queue via a message broker, and then you've got a number of consumers. But if you think about it, you haven't had to do any of the orchestration about creating that second consumer. That Azure function has done all of that for you. So that can go right up to 100 competing consumers without any effort on your part. Now, if you're doing that with microservices or PaaS or even IaaS, the amount of orchestration you need to do and hard work you need to do that is actually quite considerable. So Azure Functions are offering quite a neat way of doing distributed application processing. So there's a number of messaging patterns. I'm going to be talking about these today. So one way, which is your classic buffering of data and work, competing consumers when you've got too much work to process, remote procedure call, publish, subscribe, routing, and topics. So I'll be talking about most of those today. Oh, and scatter together. So first off, pub sub, publish, subscribe. So here you've got a source of data, which typically is routed to an exchange via a broker, and then any interested queues, then the data gets sent onto those queues, which the consumers then read out. So the source of data might not be aware of what consumers are consuming the data. They just say, I have an interest in that data, set me up a queue, and then any messages that source sends get sent out. So this is your microservices application where you've got some interested parties that want to know about updates on data, and if those parties are auto scaling, then they just latch onto the queue and consume the data as it's being brought out. So another pattern is routing. So here you take some characteristic of the data, some sources sent in here, but there's some property on the data. In this instance, I've just said that there's some kind of size property of the data, and we're saying that the large and medium instances of this data are getting routed to this queue, and the small instances are getting routed to this queue. So they might not get routed at all, but there's some, if you set up your clues correctly, then everything will get routed. And then your consumers will only get the data that they're interested in. Then there's remote procedure call. So I don't know why you'd use this one beyond an HTTP endpoint, but you set up a source of data and set a request queue that consumers are listening to. And then for each request you're making out, it sets up a bespoke response queue so that that piece of data responds to that queue only. and then scatter gather. So this is quite an interesting one. So this is kind of like compare the market. So Mr. Blogs wants his insurance quote. So the insurance quote gets routed out to all the insurers, and then Mr. Blog's personal response queue is set up. So when all of those quotes come back, all of that data is routed to his personal queue. So that's kind of a scatter gather approach, and compare the market use that. Okay, so on to the second demo. I'm going to talk about Azure Service Bus. We're going to talk about infrastructure as code. Obviously, we want to be automating everything as much as possible. Yes, yeah, okay, good. Everyone's nodding. So a way of doing that is through ARM templates, the Azure Resource Manager Templates. So we're talking about what they are. We talk about the next messaging system we've got, which is Azure Service Bus. We're talking about the topics message pattern, and then finally doing the demo. Okay, so what are ARM templates? So say, as you say, doing a file new project on an MVC project, what are the kind of assets you're going to need in order to deploy that and enable it on the web? Well, you might need a key vault, so that describes what secrets you have, connection strings and the like. You might have a SQL server, a SQL database on that server. So application insights to do a bit of logging, and an app service, which is Azure's version of IIS on demand. And then finally, an app service plan, which says how many what performance characteristics your setup has, how many cores, how much throughput and data it can do before they start billing you more. So you might need all of those things to set up your MVC project. So to do that, you use something called an Azure Resource Manager Template. So this is a snippet of one. So just talking you through that. So there's a type of database with a parameter I've fed in called the database name, which you saw in the previous graphic, and it's set into a resource group, and there's a collation type and a size, and there's an API version which describes which version of this schema it's using. So that snippet of template is enough to set up a database in Azure. You take that, all of the snippets you need, you fire at Azure, and it sets up all of the assets you need. So in Visual Studio, it looks kind of like this. You get this nice JSON outline to look at it. There's the hosting plan, PaaS on demand, some logging, and my SQL server with dependency of the database. So this is a really nice link, Azure Quick Start Templates. So this is a load of ARM templates. If you happen to want Redis and MongoDB, or IaaS, or any kind of service queues and notifications, any kind of combination of those you can find in the Azure Quick Start templates. Lots and lots of different examples to help you get those infrastructure set up that you need. So we're going to be using Azure Service Bus in this example. So helpfully they use a different nomenclature. You can set up a queue in Azure Service Bus, and a queue can only have a single consumer. And then you can set up a topic and subscription that's different to the pattern I'm going to be talking about later. And the topic and the description in Azure Service Bus has multiple consumers. You can use patterns with it, so you couldn't do that with the Azure Storage Queues. You use topics, that's topics the pattern, not topics the Azure Service Bus. Anyway, it gets confusing. Routing and pub sub. So the topics pattern. So again, we're looking at not one but multiple properties of a message here. So here I've defined 3 different properties: high or low, small or large, mail or post. So there's a source of data, sending it to an exchange, and then it gets routed to these different queues according to the different properties. So any mail gets recruited to there, any small ones to there, and high to there. So high small mail would get routed to the there, and there. Low large post would get routed to none of them, and low small post would get routed to that one. Okay. Okay, so what we're going to build. So in Azure, we're going to build an Azure Service Bus, and then I've got a small console application that produces products with those with 3 different characteristics about them: the color, the size, and the cost. And then I've got my first consumer here, another console application, and then the topics pattern set up so that everything gets routed to all products. Then I've got a second consumer that gets everything where the cost is over 80, the expensive consumer, and then I've got the light color consumer, which takes everything that's orange, white, and yellow and ignores all the other colors, and a large consumer, which ignores all the small ones. Right, so the demo is not going to work, but you can blame the university for that because they block the port that Azure Service Bus goes over. So it's never going to work. But what you would have seen is a number of messages being generated, and based on their properties that have got routed into the different consumers. Thankfully, my last demo doesn't rely on ports being open in the university. So what we're going to do here is use a different platform called Docker. I'm going to talk about why that's quite sexy at the moment. I'm going to use RabbitMQ as a messaging system sitting on Docker. We're going to use the fast and cross-platform .NET Core. Anyone using .NET Core? No, a few of you. Okay. We're going to be looking at the routing message pattern, which is similar to the topics message pattern we've seen. We're going to look at the RabbitMQ Management UI and what that offers us. And then look at setting up an exchange and a queue using both the user interface of Rabbit and PowerShell. And then finally do a demo which is build and run on .NET Core with RabbitMQ on Docker, sending and receiving messages. So, infrastructure, how do we use to set things up? Well, we used to take a Windows image and then we'd get Packer to choose the language and set some defaults for the Windows image. Then we'd use Box Starter to manage the reboots and Chocolatey to install packages. And then we'd do Vagrant up, and then you'd have an image that was about 6 gigabytes. So dragging that across the network it takes a huge amount of time, let alone starting it up. So it was very, very slow. What is Docker? Docker is extremely fast. So it's the idea of lightweight containers, which is kind of VM light. It actually sits and runs on a VM, but it's a sort of sandboxed process container with its own security model. It runs on a host operating system, so you can get Linux containers or Windows containers, and shares some of the process space for the underlying operating system, and runs on either VirtualBox or a Hyper-V host. You can't run both on the system. I just tend to run VirtualBox on my machine because there's more images for it than the Hyper-V version. There are lots and lots of different images on Docker Hub. So anything you can think of, you just do Docker pull, and you can bring down like RabbitMQ or Redis cache or something, and just do Docker run, and then you've got an instance running in the background, usually in sub 1 second. So when you compare that to how we used to do it, setting up a Windows image and installing Rabbit on it, it's sub 1 second versus 10 minutes, half an hour. Very fast to set up and start images. Docker is fully scriptable. Obviously, we should be looking to do as much infrastructure as code as possible, automated and repeatable setups. Docker has a kind of nice UI. So because we're Microsoft people, we like UI. It helps us get started, although really you should be using script to set things up. RabbitMQ uses the advanced message queuing protocol. So a standard interface to set up exchanges and queues. It's built on Erlang, so it's built for distributed applications, scalable applications. It's very easy to set up on Linux, Windows, and also Docker containers. Has an idea of exchanges, so we mentioned that briefly in the previous message patterns we've seen. So an exchange routes a message as it comes in, and usually to a queue. So we'll be setting up exchanges and queues on Rabbit, and they get mapped between exchanges and queues using a routing key. Has a concept called virtual hosts. So you might have a virtual host for your integration environment, your regression environment, UAT, and live. So it's just a way of having the same queue name and exchange name and partitioned across different areas so they don't conflict with each other. And it's got a nice web-based management UI. One thing worth mentioning about Rabbit is this NuGet package, EasyNet Queue. So it's kind of an abstraction over RabbitMQ. It simplifies a lot of things, a lot of the setup, and deals with a lot of the reliability features of Rabbit. So it's worth looking into if you're using Rabbit. There's PowerShell management for it, so I'll be doing a demo on how to set up exchanges and queues using that. So .NET Core, if you're interested in speed or cross-platform, then .NET Core is the way to go. I've heard various snooty architects refer to .NET 4.7.2 as legacy, and .NET Core is the new thing. I'm not in that camp. I'm still very much, full fat .NET is something that's very useful, but if you care about cross-platform or speed, then .NET Core is something you should be looking at. Of course, it runs on Linux, so your server infrastructure is cheaper to set up as well. One thing I'd say about using it is choose the right NuGet package. So some of the NuGet packages include all of the .NET Core symbols, and some don't. The .NET version of that package, a good example being Entity Framework, isn't a completely different package, whereas the RabbitMQ interface it has full-fat .NET and .NET Core all in the same package. And if you get the wrong one, you just get an obscure error message. So some research on choosing the right NuGet package to work with it. So we're going to build .NET Core to run inside Docker. So this is quite complex, so I'm going to step through this quite slowly. So what we're going to do is build a container image to build the C# solution, and we use a Docker file to do that. So if you imagine that this container that we're building is like our Visual Studio, so we're using a container to build the code that we want to run. And the reason we do that is for repeatability. So we create an instance of that build container, our Visual Studio container, copy the .NET Core, and then by creating an instance of that, it creates our compiled code, and then copy the .NET Core build output from that into another container, which we use a Docker file to create the image that we run. So this means that with a versioned instance of the container to do the building, we can get an entirely repeatable solution. So there's no more it works on my machine. Everything's very repeatable. So then we run the containers. So we're going to have a Rabbit receiver and a Rabbit sender instance, and we can start that using Docker run or Docker compose. So this is our infrastructure as code approach. Why are we going through this again? Okay. So we're going to look at another message pattern. So this is the routing pattern. So we've got a message broker here. And in this example, if you remember, we've got large and medium property items routing to that queue, and the small ones routing to that queue. In our RabbitMQ demo, we're going to have RabbitMQ running on Docker. So we're going to have a .NET Core sender, which creates some properties about those products, the color, the size, and the cost. That gets routed to RabbitMQ Exchange, and then the Exchange routes it to an appropriate queue. So anything that's large gets rebooted this queue, and anything else doesn't get routed at all. So it just gets chucked in the dustbin. And then we've got a consumer of that, which again is another DOS application. Say DOS, but it's .NET Core. Okay, I'm going to do the demo. Right, this is Docker Quick Start. So this is basically a Docker prompt, but it starts up Docker in the background and then sets some environment variables. Other than that, this is exactly the same as the DOS prompt. So if we do Docker PSA, that tells us if there's anything running on Docker at the moment. No, there isn't, but we can have a look at Docker images to see what images we've pulled. So there's another demo I do, SQL Server 2017. Is this big enough at the back? Yeah. And then we've got our build image and the .NET Core image that we use as a base for the container that we're going to run. And then we've got RabbitMQ, the management instance. So there's RabbitMQ without the UI, and RabbitMQ with the UI, and a very cheerful Hello World Docker container example. So just so you briefly kitematic. So this is the UI on what I've shown you there. So here are the images I can get. So if I like Jenkins, I just do create and it would download and run an image. So Redis, Minecraft, if I got bored at the office, Elasticsearch, Mongo, MySQL, whatever you want. So it just downloads and starts it off. And these are the images that I've downloaded. So if I wanted to start one of those, I could just create and it would start sub-second. So if I was using the command line, it'd be docker pull MongoDB and it would download it. I'm not going to show you that now because it takes some time. What I'm going to do is start up a RabbitMQ instance. So this is quite complicated, but I'll talk through it. No, I don't want that. Right, so I'm Docker run in detached mode, which means that I get my command prompt back, setting up a host name of RabbitMQ Demo and an instance name of LeedsSharp. Then I'm setting some environment variables. So RabbitMQ is a default username and a default password and a default virtual host. And because the security model is sandboxed, I have to open up every port that RabbitMQ needs. So there's 5 ports that run the interactions with RabbitMQ and the management interface. And I'm using RabbitMQ Instance 3 Management. So if you notice that flash on the screen, there's a RabbitMQ instance started sub-second. So if I do docker ps now, I can see that my RabbitMQ Instance Management is started up and it started 41 seconds ago. If we go back to Kitematic, I can see it's already there. So there's logs of it starting up and everything it's doing. Right, so I opened the port so I could look at the management management UI. So if I go to that, okay, bear with me. Okay. That's where it tells me it's not going to load. Oh, right, now it's loaded. Right, so I can create an exchange. I call this Bob. And then I create a queue called Sam. And then if I click on Sam, I can set the bindings between yeah, thank you. From exchange, Bob, routing key, well, let's say, let's just get everything and then bind between the two. So anything that's sent to Bob will get routed to the queue Sam. So if you go back to the exchange, Bob, publish a message, we'll say hello world. Just going to make that bigger so you can see it. So you go to the queues and Sam, and you can see that there was one message sent here, the publish rate, and if you do get messages, we can see that hello world. Right, so I'm just going to purge that queue, which means get rid of everything in it. Okay, so that's a very simple example, but when I set up something a bit more complicated, so I've got the RabbitMQ PowerShell tools to do that. So this says where the module is, and if it's not there, then import it. And then I want to set up an exchange called products, a queue name called large products, routing to a queue called large. So if the exchange isn't there, then create it. If the queue isn't there, then create it, and then create a binding between the two. Okay, so if I go back to the UI and go back to my exchanges, you can see that my products exchange is set, if you click in that, we can see that it is bound to the queue large products with the routing key large. So you expect any product to get with routing key large to get routed there and everything else to be ignored. Okay, so you've got a couple of console applications, and this time the university network won't defeat me because it's all local. So look at the sender first. So I've got 3 different sizes, small, medium and large. And then I set up my connection using the connection properties that I defined when I ran the container. And then I'm, at regular intervals, I'm publishing to that exchange various properties, various products. And then a receiver is the same, so again it's got an attachment to the queue, and when a message is received then it will process that. Okay, so those are both set up to run. Right, so on my sender, so every few seconds it generates a product, and you can see on the receiver that only the large ones are being routed to it. So that's the effect of the exchange mapping to the queue using the topics pattern. Okay, so we want that to be even faster, so we're going to get it compiled and running in Docker. So we're going to use a couple of build files here. So using the ASP.locale build image, so this is our Visual Studio image effectively. We set the work directory to be app, we copy all our project files in there, we do a .NET restore, and then we publish out to a directory called publish. So so that creates the binaries that we're going to use to create and run in the next container. So using ASP.NET Core, just a very base image, we take everything from publish and then define an endpoint called RabbitMQ receiver. So Rabbit sender is exactly the same, just for a sender. So we're going to run those. You see, very fast to build. So all I did was change the directory where the build file is, and then built the build image. Now if I create an instance of that, then I should have so there is my Visual Studio image, the image that's going to build the other image. So what happened there? So I copied the output to the out directory, so that's from the build image, and then I created the Rabbit sender image. So this is the image I'm actually going to run. It took me a while to get my head around why you'd create an image to build another image, but it made sense for repeatability. So now I've got Rabbit sender build and Rabbit sender, so I'll be running Rabbit sender. So Rabbit receiver is, so if I wanted to run that, I could just do docker run Rabbit sender in detached mode and open the ports. I'm not going to do that because I'm going to use some infrastructure as code to bring the images up at the same time. And I'm going to do exactly the same for Docker receiver, just run that quickly. Okay, so I should have two runnable images now. Yeah, Rabbit Receiver and Rabbit Sender. So again, I could run that with docker run Rabbit Receiver. I'm not going to do that. Instead, I'm going to use a Docker Compose file. So I've got a Docker Compose in scripts directory. So just go and have a look at that. So this is a YAML file. So YAML, if you're not familiar with it, it's the indenting is meaningful. So image is a subproperty of Rabbit Receiver. So I want to create a service called Rabbit Receiver, which uses my image Rabbit Receiver. So if I do Docker Compose up on that file, it will take my two images and start them. Okay. Yeah, well, that's a bit slow. Right, so yeah, we're not running in detached mode, so you see everything in the console there. It's a bit more clear if you go to Kitematic. So this is my sender, so every few seconds it's generating a product. And this is my receiver, so when a large product gets routed to it, it receives it. Okay. So I can see my running images there. Right, so I've stopped those images. Otherwise, just do docker stop or docker remove image. RabbitMQ will remove that image from the background. What we built was a Docker image with RabbitMQ running on it, and then we set up a producer of products, a source of information to post to an exchange. We used PowerShell to configure the binding between the exchange and the queue to route large products to it, and then a consumer of the large products to display the output. And we used it in .NET Core, so everything was very fast, and we used Docker Compose to bring everything up together, so that infrastructure as code concept, repeatable infrastructure. Okay, so now at this point people are phasing out because they've have a lot of information, so I'm just going to whiz through these bits quite quickly. So reliability patterns, or everything you didn't know that could go wrong. I'm going to talk about what a service bus is, so not the Azure version definition of what a service bus is, but what is generally understood as a service bus in the industry is. A bit of messaging jargon which appears in literature which you need to understand. Other types of messaging systems and some important ones you need to know about. How to select a messaging system. Spoiler alert, I don't answer the question. I'm not going to talk about event sourcing, but the slide's in there. Okay, so first off, what could possibly go wrong? Well, all I'm doing is sending a source of data to a queue and then a consumer's picking it up. What could go wrong with that? Well, actually quite a lot. The source could die between the sending the message to exchange, or the consumer could die trying to pick up the message, or you might care if the message got routed but it wasn't routed correctly, so you might want to know about that. So all of these kind of problems are done using what's called acknowledgement levels. So how much information is sent back to the source of the message to enforce reliability. So either the sender or the receiver can have connection failures. So RabbitMQ, for instance, the default provider, doesn't automatically reconnect. So you might have a nice console service, Windows service running in the background. RabbitMQ gets taken out, but it doesn't reconnect. So how do you manage that? So you can heartbeat the service to make sure it's connected, and when it comes back up, you can reconnect to it. If you see some of the performance statistics, some of these messaging systems, they generally provide the in-memory version of the queue, which means they're not persisting the message to disk. Everything's done in memory. So as you'd imagine, those performance statistics make them look really, really fast. But what happens if the broker or the queue fail and falls over? You've lost anything that's in memory at that point. So what you need to do is persist to disk, and make sure any message queues are defined as persisting to disk. You can have messaging hardware failure, so if you're running on-prem, for instance, one can fail. So typical approach to that is clustering, have multiple redundant instances of, for instance, RabbitMQ or Microsoft message queuing. You have producer failure, so the acknowledgement, let's say it sent a message and demanded an acknowledgement back, but if the producer fails, it needs to then resend the message. So you need a concept called idempotency. So for each message that's sent out, the receiver knows to not process it again, but actually just sent the original response back to the source of the data. You might have bad config, the message not being routed correctly or at all, and you might care about that, and you can define your sender and receiver so that those acknowledgement levels are set up to make sure that all messages are routed if that's what you're looking for. So EasyNet does a lot of this for you. This is this abstraction over RabbitMQ. So it does error handling, connection management, and publisher confirms, so the acknowledgement levels we've been talking about. Good article on it there. So what is a service bus? So not the Azure version of what a service bus is. So this is a layer on top of messaging systems. And this really helps in some of the reliability problems I've been talking about. So it handles retries. So what if something goes down at any point in that message chain, and it also deals with transaction management. So the two main ones out there at the moment are in-service bus and mass transit, both very good projects. So in-service bus is free for a single core instance, and mass transit is free as in air. It's an open source project. Mass transit is obviously not as full featured as in-service bus, but it's still a good product. And it deals with sagas. So you can understand this about like transactions across messaging. So say the purchaser of a product comes along, so you send a message to inventory to decrement the inventory, and then sales to charge their card, but the card comes back as denied, then you need to manage that kind of thing as a transaction. So in messaging, that concept is called sagas. So it would have some means of undoing the inventory decrement or the charging of the card as appropriate. So yeah, things you keep hearing in the literature: brokered versus non-brokered. So brokered is what's seen as a single point of failure, though you have to look at each implementation and see whether that is a single point of failure or whether they have mitigations around that. Persisted, you need to know whether your message is persisting, because if the hardware goes down, you're losing everything that's in flight. And you need to know how to deal with a dead letter queue. So in a number of examples we've seen today, you've got a listener on an event queue. What happens if that message throws an exception when it's been processed? Well, usually if a message is unprocessed, it just gets put back on the queue. But if you're processing a message that's throwing an exception every time, that's not a good strategy. So what it does is it creates a dead letter queue, dumps that message, also known as a poison letter queue, so you can continue processing. So you need to deal with your dead letters. So other messaging systems. So we've looked at storage queues, Service Bus, and RabbitMQ. Also Microsoft message queues, ZeroMQ, WebSphere, which is an IBM implementation. Again, it's chargeable, enterprise version, and Kafka. So I'll just talk briefly about those. Oh, and the event hubs. And some of you said you're using AWS SMS. So ZeroMQ can be described as a concurrency framework using sockets, which means you need to work really hard to do even basic things, let alone any kind of the messaging patterns I've been talking about today. It's a lot faster than RabbitMQ though. It's used by a lot of big companies, Cisco's, AT&T, NASA, etc. So this is the chart you'll see on the website. So ZeroMQ performance throughput is way out here, and everyone else is trailing behind. That's because it's a lot more closer to the metal as a messaging system. So if performance is really, really interesting to you, then ZeroMQ is something you should probably look at. But if you want message patterns, then RabbitMQ, ActiveMQ, or Microsoft Message Queue would probably be okay for you. So Microsoft message queuing, so this is the default option on End Service Bus. It's a store and forward system. The only messages it can do are point-to-point or fan-out, which is similar to pub/sub but not quite. It's brokerless, but for reliability you also need a distributed transaction coordinator and a cluster of servers. It's limited to Windows, but a lot of enterprises use it. As I say, it's the default option in End Service Bus, and they're used worldwide. So I was using, so I went to QCon a few months ago, and they had a streaming track, a day of sessions on streaming and one on messaging, and basically there was Kafka. So if you're in the open source space, you need to know about Kafka, and this is the real granddaddy of messaging. It can deal with those fire hoses of data. As far as QCon was concerned, there isn't any other kind of messaging system, it's just Kafka. It can do queuing and pub/sub. It's kind of like a log. It's append only, and it's used by thousands of companies, as I realized at the conference. Yeah, streams data efficiently in real time. So some of the nice things about Kafka is it has an ecosystem of applications that run into it. So you can do streaming off it, you can run it into SQL Server, Hadoop, Spark, lots and lots of different things fit into it because it has such a big user base. It's an Apache open source project. There you go. Right, so how do I select a messaging system? So this is more about the questions you need to consider when you're selecting a messaging system. So does performance matter? Are you dealing with high performance fire hoses of data? Do you need patterns? Do you need to implement some of the patterns we've seen today, or is it simple a buffer that you need? Do you perceive brokered as a single point of failure? Does your chosen message architecture have a brokered implementation without any of the mitigations? Do you care what platform has it got on? Has it got to be Windows? If so, Microsoft Message Queues or Rabbit would be appropriate. If it's Linux, you can consider lots of the other options we looked at. Do you care about the other features it might offer, like duplicate detection? Azure Service Bus offers duplicate detection. Can it be used with a service bus? So this is like End Service Bus or Mass Transit that manage sagas and manage some of the reliability aspects around messaging. And do you care that it has an ecosystem of applications that fit into it, as in the case of Kafka? Okay, so if you want to know more, there's some really good courses on Pluralsight. So RabbitMQ by example, RabbitMQ for .NET developers. It demos some of the patterns I've talked about today. Message queue fundamentals, so that deals with some of the other messaging systems I talked about. If you're interested in Docker, there's a really good course on Docker that covers some of the .NET examples as well. Syncfusion, if you don't know, they do a really good range of free books that you can download. You just sign up and they occasionally market some product to you, but the books they do are really, really good. So they do a good one on RabbitMQ. As I mentioned, the Azure Quick Start Templates is a good resource if you want to do ARM templates and set up a code. And there's a free O'Reilly book on stream processing, which is worth a good dip into. Okay, so in summary, we've seen messaging patterns today. We've seen lots of sexy technology, lots of buzzwords, and the message patterns we've seen are one-way, competing consumer, the topics pattern, and the routing pattern. Dealt with different kind of messaging systems. So for initially storage queues, where we were polling a queue, service bus, we're taking a direct feed off the queue, and then finally RabbitMQ. Bit of hipster tech. So Azure Functions, how to put your web method on the web really quickly and fast without managing any of the infrastructure behind it. And then also allowing auto scaling on that architecture. We looked at another infrastructure as code capability called ARM templates, Azure Resource Manager Templates, and setting up everything we needed in Azure in an automated and repeatable fashion. And then we use Docker Compose to take our .NET Core images that we wanted to run and stand those up quickly. And that's everything. Okay.